Okay, let's get into this. We've got some really interesting source material today you brought in.
Yeah, it looks at calculus, but maybe not how you'd expect.
Right, it feels a bit academic at first glance, but it connects to something very, well, green.
Exactly.
Plants. We've been looking over these excerpts that link differentiation and integration with how plants actually absorb carbon dioxide.
That's the core of it. The material you shared really highlights one specific connection.
Using a math tool to get a handle on a natural process, basically.
Pretty much. It shows how we can put a number on something quite complex.
So the mission for this deep dive, the question we're trying to answer, is really how does integration, from calculus,
Right.
how does it actually help us figure out how much CO2 a plant absorbs, like over its whole life? It
Hmm.
feels like a jump, doesn't it? From math class to like a forest.
It can seem that way, yeah, but the source connects it quite directly.
Okay.
What's really interesting is what the source says integration is used for here. It's computing the total CO2 absorption.
The total, not just like how fast it's doing it right now,
Nope, the grand total, the sum of everything it absorbs.
over its entire existence. Wow, how do they even calculate that?
Well, that's exactly where integration comes into play, according to the source.
Okay.
See, a plant's CO2 absorption rate, it isn't steady, right? It changes all the time.
Makes sense. Sunlight, season, age.
Exactly, all those things. So you can think of that rate as a function, something changing over time.
Uh-huh.
And the time scale the source mentions is crucial. The plant's entire life cycle.
Got it. The rate is constantly shifting.
Right. And integration is, well, it's the mathematical method for adding up all those tiny moment-by-moment amounts of absorption
Over the whole period.
over the specific interval, yeah,
Yeah.
from when it starts to when it finishes its life,
Oh,
essentially,
okay. So you go from the rate of change.
to the total amount accumulated.
Yeah.
That's what integration does, summing up change.
That clicks. So if you're, say, a college student, maybe you're deep in that calculus chapter,
Differentiation and integration, yeah.
and you're thinking, okay, but what's this for?
Right. When will I ever use this stuff?
The source basically points to this and says, here, this is a real world example.
Totally. It's not just some abstract area under a curve on a graph.
You're actually measuring something tangible, a plant's contribution over its lifetime.
Yeah, it's environmental work, you could say.
Mm.
Turning that changing rate into a single meaningful number, important for like ecology or climate studies.
It really grounds the math, doesn't it? Puts it to work understanding the carbon cycle, the impact of plants over decades, even centuries for some trees.
Absolutely. It lets scientists quantify something that's happening continuously, variably out there in nature.
It's like math is the language describing these dynamic processes.
Exactly. Translating that ongoing photosynthesis with all its ups and downs.
Into one number for its total impact. Calculus does that.
It provides that quantitative measure. That's the power of it here.
So, wrapping up this look at your source material then, the big takeaway seems to be that integration isn't just theory locked in a textbook.
Definitely not.
It's a tool, a practical one. It lets us see the cumulative effect of something happening in nature.
Like figuring out exactly how much CO2 one plant is responsible for absorbing over its entire life.
By adding up that constantly changing rate.
It bridges that gap.
Yeah.
Between the dynamic process and the final total measure.
Which kind of leads to a final thought for you listening. What other things accumulate over time?
Hmm.
Things that happen at changing rates. Where else could calculus, could integration help us understand the total picture?
Could be lots of things, right? Not just science.
Think about it. Where else is summing up change really crucial?
Once you start looking, you can probably find examples all over.
Absolutely. And that's just one way math helps us make sense of the world. Thanks for joining us for this deep dive.